Screen is visible to you all?
Yes, sir.
Okay. Today few numericals will solve because only theory it will become overdose. But please go through each and every line of theory. They are very essential if the paper is difficult. Question number 83. A small charged particles of mass m, charge q is suspended by insulated thread in front of very large conducting charge sheet of uniform surface charge density sigma. The angle made by thread with vertical in equilibrium will be how much? Sum number 83. Kama, you have the sheet?
I don't think so, sir.
No, this sheet I have not sent to you. Electrostatic wala pura?
No, sir. I don't think so, no, sir.
So, एक minute, because without that, how will you understand? Did you get it?
Yes, sir.
Open question number 83. Just read it.
A small charged particle of mass m and charge q is suspended by an insulated thread in front of a very large conducting charge sheet of uniform surface density of charge. So, how do I pronounce that?
No. See, of charge density sigma.
Sigma, okay.
So
The
this
angle
is,
made by the thread with the vertical in equilibrium is.
okay. So uniform surface charge density, large conducting charge sheet. Now, intensity at any point near large sheet. This derivation I did. Now suppose you are absent for the derivation or if you have not understood. But formula at least you can by heart. Intensity at point near charged plane sheet is given by E equals to sigma upon 2 epsilon naught. This we have proved. Are you remembering?
Yes, sir.
Last class we proved this. Now,
Yes.
okay, this is positive and this Q is positive. Positive will attract or repel? Repel.
Repel.
Huh? Repel. So this will be repelled outward. Charge Q of mass M due to force QE. Correct or not? Tell me. Force is
Yes.
QE. Okay. And its weight mg is acting downward. You want angle made by the string with the vertical. That means this angle theta. So can I say from the figure tan theta is opposite side, that is force. This side is opposite side, which is electrical force, upon adjacent side is mg. Electrical force is QE upon mg. Therefore it is Q sigma upon 2 epsilon naught into mg. So theta is tan inverse of Q sigma upon 2 epsilon naught mg. Check, do we have this option? Option A, correct? Hello?
Yes.
Yes, sir.
So
Yes.
only what we have to remember is intensity will give force, and intensity formula near charge plane sheet sigma upon 2 epsilon naught. Please copy properly, very important sum. Kamya, this one you followed, 83rd?
हाँ sir.
See, you might not have followed that formula. How we got this?
हाँ, but I understood.
Once, once you know formula, then I think it was concept. Force acting is repulsive, then weight is mg downward.
Yes sir.
Very important chapter. At least 4 MCQs are based on this electrostatic. Can I clear 83rd?
Yes, sir.
Okay. 84th. A circular plate of radius 7 is given charge of 22 outward pull per unit area. पहले मैं आपको एक one theory I am explaining. One theory I am doing. Derive expression for mechanical force acting on charged conductor. Mechanical force acting on charged conductor. Consider a conductor of any shape to be charged uniformly with positive charge having surface charge density sigma. Surface charge density sigma means charge per unit area. Let ds be the elemental area of charged conductor S1. S2 be the remaining portion of conductor. So can I consider this conductor to be made up of two parts, S1 and S2? Hello?
Yes, sir.
Let P and Q be 2 points near the conductor, outside and inside respectively. Now what I am doing, I am just bringing this S1 whose area is ds outside so that it appears to be separated. P is on the right hand side, Q is on the left hand side. This is positive charge. What is direction of intensity for positive charge, outward or inward?
Outward.
Outward. So intensity at point P and Q due to charge on S1 is given by E1. It is directed outward as shown in the figure. Have you followed this two direction part? Hello?
Yes, sir.
Yes, sir.
And the remaining surface, see, this is the remaining surface once you remove ds, which has got positive charge here. For this P is on the right, Q is also on the right. So its outward will be this way or not, tell me, for P and Q. Hello? Hello? Hello?
Yes, sir.
So intensity due to charge on S2 at point P and Q is given by E2. It is directed as shown in the figure. इतना समझ में आ गया direction वाला part?
Yes, sir.
Now
Yes.
can you tell me at P, E1, E2 are in same direction or in opposite?
Same direction.
Same direction means result is what? Add or subtract?
Add.
Addition.
And if they're in opposite, then subtraction. Correct.
Subtract.
Subtraction. So this much diagram you draw, then I'm doing the derivation wala part. Draw the diagram properly. Hello? Hello? Yeah? No, I'm not. If you're done with the diagram, tell me.
Done, sir.
Done, sir.
Okay. So you got rough idea. Intensity at point P is addition. At Q it is subtraction. Addition because same direction. Subtraction because opposite. Okay, na? Achha. See. Resultant intensity at P, comma E is E1 plus E2 because it is in same direction. Resultant intensity at Q, comma E dash is E2 minus E1. देखो E2 पे चार्ज ज्यादा है because that area is more, so E2 is greater than E1. Q is where, inside or outside, Aryan? Where is Q?
Sir, inside.
Inside. What is intensity? Yes, Aniket, what is intensity inside the charged surface?
So 0.
Zero. हाँ, अगर अंदर चार्ज रहता ना तो जीरो नहीं रहता, like solid non-conducting. So Q lies inside the charged conductor, therefore E dash is zero. This means, can I say E2 is same as E1?
Yes, sir.
Okay, very good. So from 1, I can say E is E1 plus E2. See, I know area of surface S1, which is ds. तो इसका चार्ज मिल जाएगा sigma ds, because sigma is charge upon area. So I'm trying to find intensity of second surface. That means I'm trying to find E2. So I can write E is E2 plus E2. So E is twice E2. Therefore, E2 is half of E. Clear? This much clear? Hello?
Yes.
But E,
Yes, sir.
okay, very good. But E is intensity at point P outside charged conductor. Outside charged conductor. इतना लिख लो बेटा सब लोग. Is intensity at any point outside charged conductor.
Done, sir.
You all have done? Can I clear now?
Yes,
Yes.
sir.
Is intensity at point P outside charged conductor. So therefore E is sigma upon epsilon. Charge sheet रहेगा तो 2 upon epsilon. Charge conductor then sigma upon epsilon. How I will prove after completing this derivation. Therefore E2 equals to half of sigma upon epsilon. Force. What is formula for force in terms of intensity? Force upon Q1 is E2. This you know. Force upon Q1 is E2. If I want intensity of
Yes, sir.
first, I will apply force on second. Huh? This much you remember like this. If I want intensity of 2, so I will apply force on Q1. So E1 into Q2 is force, or E2 into Q1 is force. Hello?
Yes, sir.
If E is E1, then charge is Q2. If E is E2, then charge is Q1. Okay? So force acting on conductor, comma F will be E2 into charge on S1. So half sigma upon epsilon into charge on S1 is sigma into ds. Therefore, force upon area is half of sigma square upon epsilon. This is expression for mechanical force per unit area, or F upon ds is half. I'm multiplying by epsilon, dividing by epsilon. So here it becomes epsilon square. This is half epsilon. E का formula है ना, sigma upon epsilon for a conductor. Hello?
Yes, sir.
So half epsilon into E square is also formula for force per unit area of charge conductor. You just complete, then I'm explaining how we got this E wala formula.
Done, sir.
Yeah? Just see within 1 minute how we get intensity near charge conductor. What is Gauss's law? Charge inside upon epsilon naught is integral of EDS, E bar dot ds over closure. Okay. So if I consider a charged conductor of any shape having surface charge density sigma, ds be the elemental area, let P and Q be 2 points outside and inside, draw a Gaussian cylinder. So charge enclosed will be this or not? Hello? Charge enclosed, can I write it as sigma ds upon epsilon naught?
Yes, sir.
Yes, sir.
Okay. and this is E acting outward for positive charge, so it will be E ds into cos of 0. That means sigma ds upon epsilon is E into ds. Cos 0 is 1. So sigma ds upon epsilon not E, integration of this ds is ds only because we are talking about only this much part, this full area. So ds I can cancel. Therefore E is sigma upon epsilon. Clear? Hello? Hello?
Yes,
Yes.
sir.
Now, one more small derivation, then we'll start with MCQ. Derive expression for energy stored per unit volume in the medium near charged conductor. Expression for energy stored per unit volume, sometimes also called as energy density in a medium near charged conductor. Consider a conductor of any shape to be charged uniformly with positive charge having surface charge density sigma. Let ds be the elemental area of charged conductor. So force acting per unit area is half of sigma square upon epsilon, which we have proved. So F is half sigma square upon epsilon into ds. We are interested in energy stored, that means work done against force. It is directed outwards. So force is directed outward means it will try to elongate this conductor by some distance dx. Okay, just copy this one, then I'm explaining further, hardly 4 lines more.
Done, sir.
Done. Okay. Force per unit area, we have already proved. For force we got half sigma square upon epsilon ds acting outward. So if I imagine conductor of area ds to be moved downwards by distance dx against force F, then what is formula for work done? Force into displacement.
Yes.
Yes.
Imagine conductor of area ds to be moved by distance dx against force F. Therefore work done, see we want in the medium, not in the conductor. Therefore I'm not taking minus sign. So work done comma dw is force into displacement dx.
सर
Yes.
सर लेकिन एरिया मूव कैसे होगा? वो डीएस एरिया मूव मतलब कहाँ पे होगा?
अब ये इधर आ गया है,
dx डिस्टेंस से।
इधर आ गया है सपोज पुल होके, तो इसको पीछे पुश करना है ना अपने को अगेंस्ट दिस फोर्स। तो ये वाला पार्ट ds है और ये वाला लेंथ dx लिया, आया समझ?
ओके सर।
मतलब एक कंडक्टर है,
हाँ।
सपोज ये फोर्स ने फोर्स दे दे के उसको इतना खींच लिया आगे, तो आपको उसको पीछे लेके जाना है, तो वर्क डन अगेंस्ट ये
ठीक है
फोर्स
सर।
करना पड़ेगा।
हाँ हाँ।
तो ये फोर्स आया हाफ सिग्मा स्क्वायर अपॉन एप्सिलॉन इनटू ds, और ये एक्स्ट्रा आया dx। व्हाट इज dx इनटू dx? ds मतलब एरिया, dx मतलब लेंथ, तो इसको मैं dv
वॉल्यूम।
बोलूं। हाँ, dv which is volume swept by conductor in the medium, volume swept by conductor in the medium, swept by conductor, volume swept by conductor in the medium. So from this dw will become half sigma square upon epsilon into dv, correct? हेलो,
Yes, sir.
चलो इतना लिख लो, अभी 2 लाइन और है इसके आगे। Can I clear this now?
Yes, sir.
Work done is half sigma square upon epsilon into dv. I'm clearing this. This work done is stored in the form of energy in the medium. Therefore, energy stored du is half sigma square upon epsilon into dv. So du upon dv is half sigma square upon epsilon. That means energy stored per unit volume in the medium or force per unit area, we got same to same answer. Note, energy stored per unit volume is also called as energy density. Yeah. Please copy now. Written full?
Yes.
Yes.
Energy stored per unit volume is also called as energy density. du upon dv is half sigma square upon epsilon. This also I can modify as multiplying and dividing by epsilon, half epsilon sigma upon epsilon square, half of epsilon into p square. So force per unit area or energy density formula same. Then
Yes, sir.
Yes, sir.
now come to some number 84 and 85. They are based on this theory which I explained you. 84. A metal circular plate of radius 7 centimeter. A metal circular plate of radius 7 centimeter, that is 7 into 10 raised to minus 2 meter, is given a charge of 22 microcoulomb, that is 22 into 10 raised to minus 6 coulomb. Outward pull per unit area, pull means force per unit area, placed in a medium of dielectric constant 8 will be how much? Outward pull per unit area. See, this is circular plate, so it will have charge on top as well as on the bottom, both sides. So net area will be 2 times pi r square for the plate. This is only difficult part which we forget. Now we know force upon area is half of sigma square upon k epsilon naught. So this will become half. Sigma means charge upon area. So q square upon a square into 1 upon k epsilon naught, which is half of q square. This is 2 into pi r square, the whole square, into 1 upon k epsilon naught. So 1 upon 2 q square upon 4 pi square r raised to 4 into 1 upon k epsilon naught. Copy till this, then I'm putting the values. Done?
Yes, sir.
Okay. Now just see the simplification. I'm putting the values. Of half. How much is Q given? 22 into 10 raised to minus 6. No? Hello? Hello?
Yes, sir.
अभी ये 4 ऐसे लगता हूँ. Yes, sir. 5. This 5 into K is 8. Epsilon naught into R 7 into 10 raised to minus 2 raised to 4. What is 1 upon 4 pi epsilon naught? 9 into 10 raised to
9
9.
into 10
9
raised to
into
9.
10 raised to 9.
करेक्ट. तो अपना ये 4 पाई एप्सिलॉन नॉट चला गया. 2 into pi 22 by 7 into 8 into here 22 10 raised to minus 6 22 into 10 raised to minus 6. This is 7 into 7 into 7 into 7 10 raised to minus 8. 122 we can cancel. 2 7 into 7 49, 7 into 7 49. I'm considering this as 50 so that calculation will be easy. So 9 goes up, 7 goes up, into 22 minus 6 minus 6 minus 12 10 raised to minus 3 upon 2 into 8 into 10 raised to minus 8 and into 50 into 50 into 2 is 100. 50 into 200, I'm rating 10 raised to 2. And 50 into 8 is 400. Nine into 7 into 22 into 10 raised to minus 3 upon 2 into 50 is 100 into 400 into 10 raised to minus 8. So 2 and 2 4. So 9 into 7 50 63 into 22 into minus 3 4 into 10 raised to minus 4. This is roughly 4 5s are 20. 5 3s are 15. 5 6 are 13. 3150. 5 3s are 15 31. 3150 मतलब 3000 से थोड़ा ज्यादा है क्या, देख लो जरा. Only one possibility A.
Sir, 3600 है.
Pardon?
A option.
हाँ वो A ही रहेगा ना, और कुछ हो नहीं सकता है.
Done, sir.
Okay. Everybody is done, na?
Yes, sir.
Energy intensity and energy density. Energy density means energy per unit volume. At a point in electric field are E and U. Okay. E and U. To double the energy density, U2 is double of U. The electric intensity E will be increased by nearly how much? To double the energy density, energy stored per unit volume is half epsilon into E square. This formula you have to remember first. Energy stored per unit volume, they are telling denoted by U, is half epsilon U square. So U1 upon U2 is E1 upon E2 square. U1 is U, U2 is 2U, is E1 upon E2 square. You cancel. Taking square root, 1 upon root 2 is E1 upon E2. Therefore, E2 is root 2 times E1. So, E is increased by 1.41. Root 2 means
41.
1.41 minus 1 into 100, 41%. Okay? Hello?
Yes, sir.
Yes, sir.
Do it. Do it. Yes, Kamya followed now?
Done, sir.
Sum number 86. Increasing the charge on plates of capacitor means increasing capacity. Is it correct? What is capacity? Ratio of charge to potential. Ratio of charge to potential. What is capacity? It is constant or variable? Hello? Hello?
Sir, constant.
So capacity does not depends upon capacity does not depends upon charge and potential. That means see my knowledge will not depend upon के exam tough है क्या easy है. It depends upon my inbuilt characteristics, my IQ level. So if I make one tank of 10,000 liter, so there is no need that you have to put 10,000 liter water, but its capacity is that much, which is constant. You can't increase, you can't decrease. And capacity of parallel plate condenser ये formula है ना, AK epsilon 0 by D, बराबर?
Yes, sir.
Yes, sir.
तो अभी बोला है increasing charge on the capacitor means increasing the capacity. A is wrong. A is not correct. Charge cannot increase the capacity. B. Increasing potential difference between plate. Increasing potential difference
Wrong.
between plate. Yes. Charge is directly proportional to voltage. So this is correct. Charge will increase the potential difference. So which answer? Both 1 and 2? Neither 1 and 2? Or B? Hello? Hello?
Sir, B.
B is correct option. Charge increases the potential at that point.
Done, sir.
When air in a capacitor is replaced by dielectric constant K, what will happen to the capacity? Capacity is A K epsilon 0 by D. That means if dielectric K is introduced, then capacity will increase by K times B,
Yes, sir.
because C is directly proportional. Then 88C. A spherical drop of capacity 1 microfarad is broken into 8 droplets of equal radius. What is capacitance of each drop? Whenever drop becomes droplet or droplet becomes drop, what I told, first obtain relation between their radii. Correct now?
Yes.
So can I say 4 by 3 volume of this drop 4 by 3 pi r cube should be equal to 8 times 4 by 3 pi small r cube. 4 by 3 pi cancel. So taking cube root, r is 2r. What is capacity of sphere? Anything capacity is q by v. For sphere, potential, you know it is 1 upon 4 pi epsilon q by radius. Q cancel. So capacity is 4 pi epsilon 0 r of spherical conductor. So I can say C of large upon C of small is radius of large upon radius of small. C of large is given 1 microfarad. C of smaller you want. Capital R is 2R. Upon this R cancel. So C of small is 1 upon 2 microfarad. Very beautiful sum. Copy.
सर आर स्क्वायर होगा ना?
नहीं, आर स्क्वायर फॉर्मूला क्या आया? 4 पाई एप्सिलॉन 0 आर है ना. पोटेंशियल का फॉर्मूला होता है 1 अपॉन 4 पाई एप्सिलॉन क्यू बाय आर. इंटेंसिटी होता है आर स्क्वायर. ठीक है ना?
सर लेकिन कैपेसिटेंस एरिया पे भी डिपेंड कर रहा है.
नहीं, अब
पाई आर स्क्वायर हो.
कैपेसिटेंस वो पैरेलल प्लेट कंडेंसर में ए के एप्सिलॉन 0 बाई डी होता है. ये स्फेरिकल ड्रॉप है ना.
Okay.
तो कोई भी जनरल
हाँ,
कैपेसिटी,
ठीक है.
किसी का भी कैपेसिटी क्यू बाई वी फिक्स है. फिर
ओके सर.
हाँ
थैंक यू.
ठीक है. नेक्स्ट लेक्चर में मैं पूरा वोल्टेज एक्सप्लेन करूंगा. अभी क्या बहुत ज्यादा थियरी भी हो जाएगा तो बोर हो जाएगा ना, इससे आज न्यूमेरिकल किया थोड़ा. Done.
Yes, sir.
Next one. 89th. Capacity of an isolated sphere is increased n times when it is enclosed by an earthed concentric sphere. Then ratio of radii is this. If you take small r, this is capital R, ratio of radii will be how much? What increases n times? Capacity. So this C2 is n times C1, correct? ये मीनिंग दिया है ना.
यस सर.
अभी C1 का कैपेसिटी मुझे मालूम है, आपको ही मालूम है. व्हाट इज C1 का कैपेसिटी? स्फीयर है इसलिए सिंगल स्फीयर है. 4 पाई एप्सिलॉन 0 r बराबर.
Yes.
सो अगर ये C2 मिल जाए विच इज लाइक कंडेंसर, तो आई गेट फॉर्मूला कंडेंसर के लिए इट इज चार्ज अपॉन पोटेंशियल डिफरेंस. हेलो.
Yes, sir.
So if
Yes, sir.
this is having charge positive, तो इसको इलेक्ट्रोस्टैटिक इंडक्शन से नेगेटिव मिलता है ना, बराबर.
Yes, sir.
तो आई एम इंटरेस्टेड इन पोटेंशियल डिफरेंस. पोटेंशियल डिफरेंस equals to V1 minus V2. I think this also you follow. हेलो.
Yes, sir.
ये फर्स्ट है सेकंड है ना, तो फर्स्ट वाले का पोटेंशियल माइनस सेकंड वाले का पोटेंशियल विल बी पोटेंशियल डिफरेंस. व्हाट इज पोटेंशियल ड्यू टू चार्ज ऑन दिस स्फीयर? 1 upon 4 pi epsilon naught charge I take q upon radius r. I hope you follow.
Yes, sir.
रेडियस स्मॉलर है इनर वाले का. आउटर वाले का 1 upon 4 pi epsilon q upon कैपिटल R. हो गया कॉन्सेप्ट समझा इधर तक? हेलो.
Yes, sir.
Yes, sir.
कल पूरा पोटेंशियल ही कराने वाला आपका, तो ये सारे चीज करा लूंगा उसमें. सो दिस विल बी 1 upon 4 pi epsilon q common inside 1 by r minus 1 upon capital R. That will become 1 upon 4 pi epsilon q capital R minus small r into RR. Okay. Hello.
Yes.
Yes, sir.
Now C2 is q upon potential difference or not, as per formula.
Yes, sir.
So q, this is 1 upon 4 pi epsilon naught q r minus r upon RR. Can I cancel this q? हेलो, इज इट
Yes.
विजिबल? हाँ. तो अभी C2 क्या हो जाएगा? 4 पाई एप्सिलॉन नॉट प्रोडक्ट आर आर अपॉन आर माइनस आर. आई थिंक यू गॉट द आइडिया दिस मच.
Yes, sir.
Okay, copy first and second equation तक. Then just it is dividing 1 by 2 and putting appropriate relations. So potential of sphere of radius r, capacity of sphere of radius r 4 pi epsilon 0 r. For concentric sphere we have to find potential difference. तो ये negative वाला charge will give negative potential at center. Potential on the surface or inside is always same. Potential for charge is 1 upon 4 pi q by small r for inner one, and outer negative will give minus of 1 upon 4 pi q by r. 1 upon 4 pi epsilon qi took common, 1 by r minus 1 by capital R. So 1 upon 4 pi epsilon q capital R minus small r upon RR. So from this capacity is charge upon potential difference. Charge is q, potential difference 1 upon 4 pi epsilon q r minus r upon r into r.
So done.
Small r upon capital R and minus 1 upon n. Very important. Something you have sent, Aryan Singh?
Yes, sir.
हाँ
So
कॉमन
there
में
are more questions I wanted to.
डायरेक्ट कॉमन में भेजो चलेगा ऐसे. ये एक ही डाउट है. हेलो,
नहीं सर, और है question.
तो आप भेज देना सब, फिर कल मैं आपको पूरा डिस्कस कर लूंगा. ठीक है.
ठीक है सर.
ये तो रिंग वाला मैंने कराया ना आपको. रिंग ऑफ चार्ज 0.5 has this much meter gap. If the ring is carrying charge of 10, the electric field at the center. चलो ठीक है.
सर
कल
गैप
कल
मतलब वहाँ वो सम.
उसको कुछ नहीं फर्क पड़ता है क्या.
ठीक है सर.
That's all for today. Tomorrow again, same time, all potential related things will be doing.